Thank you. And I want to say thank you for PTV for selecting us, myself and Akshay. I'm not even going to try his last name because I never get it right. He actually was in our San Antonio office. I'm out of our Houston office, but he's recently moved to California. And so we actually worked on this project a couple years ago. And so once again, a disclaimer on the versions. I do want to mention this is not a groundbreaking, presentation on major, technical analyses. The focus of this interchange or of this particular project was number one to focus on some Vissim options and features that sometimes when we get down into the weeds, we forget. And also, especially more for the clients that may be in the room or may see the presentations, that to remember that TCP strategies are something that can and should be analyzed in some situations. So that's kind of the focus. I have a couple videos to kind of give some more information. But just really main presentation goals for this particular presentation is recognize that traffic flow impacts related to traffic control or maintenance of traffic, depending on what it is. Everyone knows that, but depending on where you're at, it can make a big difference on ultimately, sometimes with those in this room, we are trying to let the civil engineers doing the actual roadway design understand is that sometimes you need to look at maybe an exit that's being closed or something else to understand what the true impact is. Understand the importance of traffic simulation, and that's what one of the focuses is. Oftentimes we develop a simulation for a design. We calibrate the model, and then we go off and run all the alternatives, but we don't really get to use that existing model more. And so that's something that just want to reiterate that's a good component and use of the model itself. And then a whole host of different interpreting results. Vissim has come a long way. I'm not going to tell you what version I started in using Vissim, and so come a long way with some of the visuals that can occur. So that once again, some of those aspects from Vissim, makes our life a little bit easier. I actually did have this in there before the FHWA presentation, so it's not like I saw that and then hurried up and added a slide. I did want to mention, that this once again is discussed in the Traffic Toolbox Volume 12 about work zone analysis. And then on the left here, on the right, you can see it doesn't necessarily mean that you have to use a simulation tool, but you'll see in this case, for a couple reasons, it was selected. But you do sometimes need to look at your TCP in a planning during your PE and design component, and then again maybe during construction. And so that's what made this particular project a little interesting. So just to give context, Texas is a big state. Here is Houston, and this particular project is about 2 hours east of Houston, closer to the Louisiana border. It's in a town called Port Arthur. Probably never heard of it, but it is a major chemical plant. So there's major chemical plants, not in the oil world, but on the chemical side. And so there's a lot of traffic that comes in and out of these locations. Number one, for the port, obviously, and then to deliver and send out product per se. And so at this particular, this was our study area, relatively small study, a cloverleaf, one of very, very few still left around, especially in Texas, but very excellent corridor with US 69, typical two lanes in each direction, highway, not up to freeway yet, and then FM 73, very similar as well, and both of these provide direct access to the port and to the chemical plants. Cloverleaf, just existing project that was, ultimately TxDOT wanted to improve this particular interchange, and they looked at a lot of different analyses. We were given the project after the decision of what the project was going to already be, and so you'll see that here. We'll look at what is some of that history. They did look at traditional interchange with direct connectors, and if you've ever been to Texas, our direct connectors are very, very large. They're not just a simple little DC. I should have had a picture to give context, but some of our direct connectors can be a half a mile long to get rid of that weaving. And so it becomes a very costly interchange. And so that was one of the reasons why when they did the VE study, they said, we can't, imagine spending 60 or 70 million on a connector, DC connector interchange. The existing interchange did have some very poor levels of service. Obviously, you can imagine with cloverleaf speeds and the volumes on the ramps are obviously the highest here, where you create a very large weave, and that creates safety and congestion problems. And you can see that 12,000 on this ramp here, 14,000 on one of the ramps that are coming here, and these are existing. These would have been 2019 volumes before the pandemic. So we obviously then were given the project to increase and forecast the volumes. I don't actually show that in here, but I just wanted to mention that the analyses that you're going to see and we discussed are based on the future. So TxDOT once again wanted to reconfigure the cloverleaf interchange, and what they ultimately decided on was a turbine configuration, which aren't very many of those around. You'll see here in a minute, but those really addressed the questions, as Chong said the other day, is why are you doing the simulation? What's the project for? And so in this case, the turbine interchange met some direct connectors, but not the large big ones that we typically would think of. Obtained the frontage road. We in Texas like frontage roads, so we included those. And then more from the design perspective, constructing retaining walls and your typical elements for construction on a project. Mainly, it was to improve safety and mobility and connectivity to Port Arthur, and then to modernize the interchange to current TxDOT standards. So here's the cloverleaf. Here's the turbine. So it's somewhat of a compressed, what I would call a DC, where instead of having the large, that was not working, but instead of the connectors going elevated the entire way, they're kind of compressed and brought down so that you're saving that cost, but you're still maintaining and benefiting from the traffic flow environment. And so that was a real important part. The music's great, so we'll just let it go. So this is one of the features within that Vissim gives us as the ability to take the animation, the trajectory info, and then bring that into an animation. And so you can see this does take more than half a day, that was mentioned earlier. But for public involvement, this is a very important tool. And so you can see these are actual, trajectories from Vissim put onto the animation itself. Well, and then our visualization experts can put in the signing and everything to really give it that full feel. And so when they are talking to to maybe the chemical plants or some of those other stakeholders, they can see a little bit more perspective. They do get the elevation, of the bridges and where everything is going to be in a much more realistic. And so I know Vissim has made PTV, Vissim, I always look at it the same. They've made that ability a lot easier than it used to be. So it is something that sometimes, if you have the opportunity and you really need to sell a project, this is another feature. Maybe one day they'll incorporate it all, but that's probably going to take a lot. So we don't want to watch it again. And so one of the other elements back in the old days, we didn't have these pretty little figures that you could do within Vissim. And so, as I mentioned earlier in one of the presentations yesterday, I think, some of these are nice enough that you can put them in an appendix. You can add them in a PowerPoint like you see here, without having to go do and create all of your figures again. And so this just gives a very quick looking at density. Since both of these are freeway type roadways, it's just very quickly you can tell what the speeds of the turbine was at the different times. And yes, you will see that there is a ramp that is still not performing great in the year 2040. And so there was some additional modifications that we had to make. You can't see it at all. Upward just south of the US 69, right in here. We still had to make some geometric improvements and tell TxDOT in 10, 15 years, you're going to have to widen US 69. Otherwise, the corridor is going to break down before the interchange will. So that's another thing that simulation helps, which we in this room know that, but just to reiterate that. And so I'm getting to the TCP. I know you're probably thinking, but I still have time because we only had 3 presentations, so I've got what, half hour still? No, I'm kidding. So in this case, just really quick, shows you the no build scenario, and it's very easy to create some very nice graphics all within the Vissim platform. So that really helps us on that side to not have to create and keep redoing graphics. But you can see, very easily that, everything's green. Everyone knows that that's good. So you can put the legend there, and it's a very easy way to show. Okay, so now that was looking at the existing, cloverleaf, changing it to a turbine. So that was the main focus of the project. And what TxDOT said is that, hey, we want to save money and build this project. We don't want to belabor it and have it go out for multiple years. As we all know, the quicker you can, shut things down, crank it out, the better off it'll be. Well, TxDOT made a really big, profound statement. Well, let's just shut the whole all of the cloverleafs, all of the elements in white. We're just going to shut all of those down and detour. And so obviously that creates some panic with some people. And so, we were asked to look at, different scenarios. Let's close this ramp down. How does that impact? Well, let's close this ramp down. And so this is another feature of having the scenario manager. This was a great tool to be able to code those and, kind of filter them through and be able to, do your base network, your base geometry once you've got it calibrated. And once again, we're looking at the existing network. We've already done the proposed and we're finished. Well, now let's look back at that calibrated model that we spent time on. What could happen? What things could we do to let TxDOT know it's going to work or it's not going to work? And so this just further goes through looking at creating modifications and then creating those different scenarios as you've seen here in the past. And I think we were lucky when we started this project. I don't think the scenario manager was in, and by the time we got to this task, we were able to take advantage of it. And so this is just a list of some of the names, looking at Detour 1. We ended up doing the PM because that was the worst case in all scenarios. And then you have a description, what are the combination of detours. And so you could look and really test something. And so if the client said, well, hey, what about if we do 3 and 4? You could do that. It didn't. Well, I'll have to get back with you in a couple days. You'll be able to do it much quicker. And so Akshay created this nice little video once again, just to kind of show, looking at the scenario manager up at the top, showing the, down here that what it's being closing a ramp, and just to kind of give those that maybe don't use it often, just to kind of showcase those. And so you can build upon each other. And so it made it very easy to go back in time and check something or whether or not it was. I think that's it. So in this particular case, it's not going to take I think this is one more. I think that one more. Maybe I think it went to the same thing. Sorry. So it doesn't take really, rocket scientists to figure out if you close all of the cloverleaf, and you detour people. In this particular case, we did not do any shifting of traffic or diverting the traffic. And you can see the red, it goes up and goes all the way up to here. And so we were trying to, so there were detours in traffic coming down into this little interchange and then circling back. But what the goal that TxDOT wanted to find out is, were there some, improvements at the interchange that they could make during construction to try to improve. We kept reiterating, getting CMS, changeable message signs, out in the field and telling people, go somewhere else, go another way. And so when you did, in combination with telling people to divert, as well as make this particular Savannah interchange did not have a U-turn, a standalone U-turn. And so that was something that was recommended. Add in the U-turn so people can make that movement without going through the actual interchange. And so by doing that and saying that, let's say 30% of the traffic was going to go on a detour, for example, and we did some signal timing and we added the U-turn, you could see that, we did get some improvements throughout the corridor in that regard. But it was that ability to be able to not only know that, it's going to be bad, but what are some improvements that we could make. And so that was for the big interchange. And then as they were just about ready to start the actual construction of the interchange and some other items, one of the, this is the Savannah interchange, which is down right on 73. One of the large chemical plants that are right in this area down here. When they do construction in Texas, they also do construction very large. And so when they do construction on these chemical plants, they're massive. And so this particular chemical plant was going to send out a construction traffic of another 1,000 vehicles added to the network. And so, they also now then came back so they could tell the chemical plant that, obviously if you put all this traffic here, it's going to overload the interchange, and what other improvements could we make? And once again, to show the chemical plant that you really, you need to do some shuttles and you need to do some other proactive improvements to be able to handle that traffic. But what was nice is they were being proactive. So once, whatever did happen, we don't know yet, because I don't think they've fully started that yet, but they are doing some of the updates to the interchange, this interchange ahead of time before they close the actual interchange itself. And so this is the last. Yeah, I guess you can see. So this is down below was going to be the congestion that was going to occur. And then as you see up above, when you do the U-turn and you do some, I don't recall the diversion that we had anticipated to get the level of service down into reasonable. But you can see it, with those ramps closed and with a diversion, that was going to have to be something that was going to be part of their plan. And obviously with the construction component, that just added even more traffic to the mix. And so constantly being able to, they actually upgraded some of the signal equipment at the interchange, even though that was only going to do a certain amount. But at least they were being proactive and being able to try to get some of those things ahead of time. So that's that. And then I think that brings us, if it will let me go. There. So as I said, no earth shattering, things here, but just once again, focusing on just remembering, that sometimes when we get engrossed in different things that, just kind of remember some of those other things about the, bringing in your vehicle trajectories into and creating a good animation can go a long way with your different public makers. But, obviously go through that during the scoping phase. And if it comes up later, it is something that you can do if you have the ability to. We all understand the importance of simulation in this room, so I won't reiterate that. Just remember the graphics that are inside. Most everyone in this room obviously knows that as well. But sometimes, and I know we talked for a couple different people, is Vissim is constantly updating and improving, and whoever knew that we would have 2023 coming out. That for those of us who've been using Vissim that just seems like a very large number of, just it seems like a lot. So just keep remembering sometimes those features we forget about because they're coming out with great new and advanced ones. But just I just want to point that out that TCP is an important thing, especially on design build projects. We do those a lot where we require the contractors to actually do a Vissim network to show the owner that, hey, if you're going to do this and this, then you're either not going to be allowed to, or you're going to pay a penalty for that. So that's just another component for that MOT strategy when you get into these big, highly congested corridors that have, like we mentioned earlier, 212,000 vehicles.